The next section that we are going to look at is multiplying and dividing signed numbers. This comes from section 1.5. For our toolbox, we need to know how to multiply whole numbers. If this is something you struggle with, you may want to make flashcards so that you know your multiplication rules. Upon completing this section, you will be able to understand how to multiply two or more signed numbers, know and be able to apply the 4 properties of multiplication. Alright, so let's look at an example of how to visualize our multiplying signed numbers. We're going to revisit our using manipulatives, and again, we're going to use blue chips for positive numbers and red chips for negative numbers. All right, so in order to think about multiplication using manipulatives, the first thing that we want to do is if the first number is negative, we're going to ignore the sign for now. We're going to take care of our multiplication, and so the first thing that we want to do is note that the first number, we're going to let it indicate the number of sets, and we're going to let the second number indicate how many and what color appear in each set. So we'll go ahead and lay out however many this results in, and once we're done with that, we want to take into account if the first number was negative. If the first number is negative, we want to swap all of our colors for the other color. When we think about the first number being negative, we want to think of it as being the opposite. So the opposite of blue is going to be red, and the opposite of red is going to be blue. All right, let's go ahead and look at some examples and see what we can do here. All right, example A, we want to multiply 4 times 3. Both of these are positive, and so what we're going to do is I have my set of 3 here, and so I want to go ahead and have 4 of these. So we have our 4 sets of 3, and if we total this up, we get that this is equal to 12. And so we get 4 times 3 is equal to 12, and you probably knew that already. All right, so we have that one. Okay, let's look at another example, and we'll start getting into our negatives here. If we look at example B, we have 3 times negative 2, which means that I want 3 sets of 2 red chips. So we have our 2 red chips here. So I'm going to go ahead and create 3 of them. Since our first number is positive, we don't change our colors, and so what we essentially have here is we have that this is equal to 6 reds or negative 6. All right, let's come up to example C, and we're going to move the negative on the outside now. And so remember, if we have the negative on the outside, we're going to ignore it for now. And what we're going to do is we are going to go ahead and create 2 sets of 4 blue. So I've got my 4 blue here, and I'm going to create another set. Now we want to take care of the negative on the outside. And what we're going to do is basically turn all of these red. And so what we end up with is 8 reds or negative 8. All right, and our last example, we have negative 3 times negative 5. So the first thing that we want to do is, again, we're going to ignore the negative in the front. I want 3 sets of negative 5, or 3 sets of 5 red chips. So we're going to go ahead and start with that. And now we want to take care of our negative. And so our negative on the outside, the first negative, means we're going to change all of these to blues. And so what we end up with here is positive 15. And so negative 3 times negative 5 is equal to 15. All right, let's look at a couple other examples of how to think of multiplying negative numbers. Another way to remember multiplying and dividing signed numbers is the karma lesson. The karma lesson says this: when good things happen to good people, it's good. So a positive times a positive is equal to a positive. When bad things happen to good people, it's bad. I'm going to go under the assumption that you are a good person. Going under the assumption that we are all good people, if you think about when bad things are happening to you, we always want to sit there and say, what did I do to deserve this? Because I'm a good person. So when bad things happen to good people, it's bad. For example C, we have when good things happen to bad people, it's bad. I'll provide an analogy of this in class, but remember, in order for all of these to make sense, you do have to be a good person. If a murderer gets off in court and does not go to jail, then justice was not served. So when good things, not going to prison, happen to bad people, people who should be in prison, then we have a tendency to not like it. The final statement, when bad things happen to bad people, it's good. If you think about it, going to prison, not a good thing, but if you deserve to be in prison, it is. So a negative times a negative is equal to a positive. For more than two numbers, consider the following dialogue from The Big Bang Theory. This is one of my favorite scenes. So, Sheldon says to Amy, this is before they start dating, I would not object to us no longer characterizing you as not my girlfriend. So let's see what we have here. Our negatives, not and object, are both negatives. No longer is a negative, and not is a negative. Upon that, Amy says, now try it without the quadruple negative. So this very long statement is, fine, Amy, will you be my girlfriend? If you have an even number of negatives like this example here, they all cancel out, leaving you with a positive. So there are some examples in terms of English or in terms of real life. These are other ones that you can use to remember multiplication. So let's talk about multiplying signed numbers and our procedure. Just like with addition and subtraction, or combining numbers, the first thing we want to do is our operation. We're going to multiply the numbers disregarding the signs. Now multiplication and also division is also much easier than adding and subtracting, because no matter what, if it's a multiplication problem, you always multiply. Similarly with division, you will always divide. So how do we determine what the sign of the answer is? The sign of the answer has to do with how many negatives are in the problem. The sign of the result is positive if multiplying two numbers that have the same sign. We can extend this to the sign is positive if there is an even number of negatives. The other case we have is the sign of the result is negative if multiplying two numbers that have different signs. The sign is negative if there is an odd number of negatives, if you want to extend it out. And finally, one last thing that we need to know about multiplication. The product of 0 and any real number is 0. So let's go ahead and use this and look at some examples. If we look at example A, we have 6 times negative 3. I want to start by multiplying the numbers, disregarding the signs. We get 18. Since I have only one negative, I keep it with my answer. For example B, we have negative 9 times negative 10. Again, I want to multiply my numbers, disregarding the signs. And now, since I have two negatives, my answer will be positive. Another thing you can do is kind of what we did when we talked about subtraction. If you want, you can go ahead and cross out negatives in pairs. Since both of my negatives cancel, then I have my final answer of positive 90. Example C, we have negative 1.4 times negative 2. I'm going to go ahead and multiply the numbers. We get 2.8. And again, since it's an even number of negatives, it becomes positive. Or I can cross out two negatives, leaving me with no negatives in my answer. Example D, we have negative 372 times 0. Anything times 0 is 0. Let's look at example E. Now, even this one, we can go ahead and just multiply all of the numbers disregarding the signs, and then we'll put the sign in at the end. So 4 times 3 is 12 times 2 gives me 24. I have a total of 3 negatives. Since that is an odd number, my answer will be negative. Or, remember, we can cross out negatives in pairs. Since I still have one negative left, my negative will stay with the answer. Let's look at example F. We have negative 3 times negative 1 times 2 times negative 2. If we multiply the numbers, 3 times 1 is 3, times 2 is 6, times 2 is 12. I have a total of 3 negatives in the problem, and so my answer will stay negative. Or again, you can cancel out 2 of them. We still have 1 left over. For example G, we can go ahead and multiply the numbers. We get 1 times 2 is 2. Times 2 is 4. Times 3 is 12. Times 4 is 48. I have 4 negatives in the problem. Since this is an even number, my final answer will be positive. Or, if we cross them off in pairs, we have no negatives left to put in our final answer, and so our answer will be positive. So now let's look at some problems involving multiplying fractions. If we start with example H, what is our procedure for multiplying fractions? Recall that with multiplication, we have 2 basic things we need to do: multiply straight across and cancel common factors. And recall that these things can be done in either order. I'm going to go ahead and cancel first. So I want to look at numbers on the top and numbers on the bottom and see if they are divisible by a common factor. So on this one, I have 15 and 3 are both divisible by 3. If I divide 15 by 3, I get 5. If I divide 3 by 3, I get 1. I can also divide 2 and 16 by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. If we multiply straight across, we end up with 5 over 8. For my sign, I still have a negative, and so I'm going to keep it with my answer. We get a final answer of negative 5 over 8. If we look at example I, same thing. I want to start by canceling common factors. 3 and 9 are both divisible by 3. If I divide 3 by 3, I get 1. If I divide 9 by 3, I get 3. 4 and 8 are both divisible by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. I can now go ahead and multiply straight across. I get 1 times 2 is 2. 1 times 3 is 3. And now I do need to take care of my negatives. We have a total of 2 negatives. Since this is an even number, my answer will be positive. Or again, you can go ahead and cross out 2, leaving you with no negative for your final answer. For the last problem, J, we have 5 over 6 times negative 8 over 9. If we cancel common factors, what can we cancel? The only numbers that have common factors here, in terms of being on a top and a bottom, is 8 and 6. Both of them are divisible by 2. If we divide 6 by 2, I get 3. And if I divide 8 by 2, I get 4. As that's all that cancels out, we can now go ahead and multiply straight across. We get 5 times 4 is 20 over 3 times 9 is 27. I still have 1 negative, and so I want to put a negative with my final answer. So our final answer is negative 20 over 27. So there are some examples of multiplying signed numbers. One thing to keep in mind is that signed numbers, for many of us, is the bane of our existence. We have a tendency to just drop them. One of the first suggestions that I have for you is to highlight negatives so that they stand out a little bit more. especially when working with the fractions. It's very easy to lose negatives when we start canceling common factors. The last thing to look at here is our properties of multiplication. Just like we saw with addition, we have some of the same properties when it comes to multiplication. The first one we have is just like we saw with addition, we have similar properties for multiplication. The first one we have is the multiplicative identity. Remember that identity in terms of math means that it does nothing. Our multiplicative identity is 1. Anything times 1 is itself. A times 1 is A, 1 times A is A. The other operation that we have, or the other type of number we have, is multiplicative inverse. Inverse, just like with addition, cancels out. When we talk about multiplicative inverse, what we are looking at is the reciprocal of a number. Two multiplicative inverses multiply to 1, or the identity. So A times 1 over A is equal to 1. 1 over A times A is also equal to 1. Now, when we talked about addition, one thing to note is every number has an additive inverse. When we talk about multiplicative inverse, not every number has a multiplicative inverse. 0 has no multiplicative inverse, since 0 times anything is always 0. There is nothing you can multiply 0 by in order to obtain 1 for your answer. That brings us to our multiplication properties. We have the commutative property. Remember that the commutative property for addition and also multiplication means changing the order does not change the result. If you think about multiplying large numbers, let's say a 2-digit number by a 3-digit number by hand, in general, we always like to put the larger number, or the 3-digit number, or the number with the most digits on top, irregardless of where it is in the problem. So we have A times B is equal to B times A. Another property that we have, or the other property that we have, is the associative property. And the associative property says changing the grouping does not change the result. So I can multiply my last two numbers together and multiply the result by the first number, or I can multiply my first two numbers together and multiply that by the last number. Again, it all depends on how you want to do it. Multiplication, just like addition, has lots of freedom to it. This finishes off multiplying signed numbers. So when will we see this again? Throughout the course, we will be working with signed numbers and our 4 basic operations. We will expand the concept of multiplying signed numbers when we talk about simplifying expressions involving variables. We will also expand the concept of multiplying signed numbers when we expand the concepts when we talk about polynomials and negative exponents. Also, when we get to factoring polynomials, we will need to be able to think backwards. For instance, what do you need in order to multiply to a negative number? Or what do you need in order to multiply to a positive number? Once you understand the presentation to the best of your ability, try the following problems on your own and bring them to class along with any questions that you may have.